Yes, it is permissible to wire both lights and receptacles on the same bedroom circuit provided that the circuit is protected by an arc fault circuit interrupter, or AFCI breaker. As long as the circuit is wired correctly and there are no actual arcing faults present, the AFCI breaker should not trip. There are several crucial considerations when wiring lights and receptacles on the same AFCI circuit. Firstly, it is imperative to select the appropriate wire size for the circuit's intended load. Typically, 12/2 wire is suitable for 20 amp circuits, which are commonly employed in residential settings. Secondly, avoid overloading the circuit. The cumulative amperage of all devices connected to the circuit must not surpass the amperage rating of the circuit breaker protecting it. Thirdly, employ proper wiring techniques throughout the installation process. Ensure that all connections are secure and tight to minimize the risk of loose connections and potential arcing. Fourthly, rigorously test the completed circuit to verify its proper functionality and adherence to safety standards. The proper wire size ensures that the circuit can handle the expected load without overheating, reducing the risk of fire. Overloading a circuit can cause the breaker to trip frequently, indicating an unsafe condition. Proper wiring techniques are essential for preventing loose connections, which can lead to arcing and potential fires. Testing the circuit after wiring confirms that everything is working as intended and that there are no hidden problems. Let's elaborate on each of these points. When choosing wire size, consider the amperage rating of the circuit breaker. For a 20 amp circuit, 12 gauge wire is typically recommended. However, for a 15 amp circuit, 14 gauge wire is usually sufficient. Refer to the National Electrical Code, specifically NEC Table 310.16 for guidance on conductor ampacity based on wire type and insulation. Remember that using a wire gauge smaller than what is required by code can lead to overheating and potentially cause a fire hazard. When calculating the total amperage of the devices on the circuit, consider both the lighting load and the receptacle load. For lighting, use the wattage rating of the light fixtures and divide by the voltage of the circuit, which is typically 120 volts in residential homes, to determine the amperage. For receptacles, estimate the load based on the types of appliances or devices that are likely to be plugged into them. A general rule of thumb is to assume a continuous load of 80% of the receptacle's rating, especially for general-purpose receptacles. The NEC provides guidelines for calculating branch circuit loads in Article 220. When making electrical connections, use appropriate connectors such as wire nuts or terminal screws. Ensure that the connections are tight and secure to prevent loose connections, which can cause arcing and overheating. Use a torque screwdriver to tighten terminal screws to the manufacturer's specified torque rating. When using wire nuts, strip the insulation from the wires to the correct length and twist the wires together tightly before applying the wire nut. Always follow the manufacturer's instructions for the specific type of connector you are using. After completing the wiring, test the circuit to ensure that it is working properly. Use a multimeter to measure the voltage at the receptacles and light fixtures to verify that it is within the acceptable range, typically 110 volts to 125 volts. Use a circuit tester to verify that the receptacles are properly grounded and that the polarity is correct. Use an AFCI tester to verify that the AFCI breaker is functioning correctly and will trip in the event of an arcing fault. The AFCI tester simulates an arcing fault to test the breaker's response. Here's a deeper look into AFCI breakers. AFCI breakers are designed to detect arcing faults, which are dangerous electrical conditions that can cause fires. There are two main types of arcing faults: series arcs and parallel arcs. Series arcs occur when there is a break in a single wire, while parallel arcs occur when there is a short circuit between two wires. AFCI breakers use sophisticated electronics to detect the unique signatures of these arcing faults and trip the breaker to interrupt the flow of electricity. The NEC requires AFCI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. The specific requirements for AFCI protection can be found in NEC Section 210.12. When wiring an AFCI circuit, it is important to use high-quality wiring devices and connectors. Avoid using damaged or corroded wiring devices, as these can contribute to arcing faults. Use properly sized wire connectors and ensure that all connections are tight and secure. When installing the AFCI breaker, follow the manufacturer's instructions carefully. Ensure that the breaker is properly seated in the panel and that all connections are tight. Test the AFCI breaker after installation to verify that it is functioning correctly. Here are some additional tips for wiring lights and receptacles on an AFCI circuit. Firstly, plan the circuit layout carefully to minimize the length of the wiring runs and the number of connections. Shorter wiring runs and fewer connections can reduce the risk of voltage drop and arcing faults. Secondly, use a dedicated neutral conductor for each circuit. Sharing a neutral conductor between multiple circuits can cause the neutral conductor to become overloaded, which can lead to voltage drop and other problems. Thirdly, avoid running the wiring through areas where it is likely to be damaged, such as attics, basements, and crawl spaces. If you must run the wiring through these areas, protect it with conduit or other approved methods. Fourthly, use a surge protector to protect the electronic devices that are plugged into the receptacles on the circuit. Surge protectors can help to protect against voltage spikes and surges that can damage electronic equipment. Finally, if you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or death. The NEC is updated every 3 years, so it is important to stay up to date on the latest code requirements. Consult with a qualified electrician or electrical inspector to ensure that your wiring installation complies with the current code. Using appropriate tools is very important. When working with electrical wiring, it is essential to use the proper tools to ensure safety and quality. Some essential tools include wire strippers, pliers, screwdrivers, and a multimeter. Wire strippers are used to remove the insulation from wires without damaging the conductors. Pliers are used to grip and bend wires, as well as to tighten connections. Screwdrivers are used to tighten terminal screws and other fasteners. A multimeter is used to measure voltage, current, and resistance, which is essential for testing and troubleshooting electrical circuits. Always use insulated tools when working with electricity to protect against electric shock. Before starting any electrical work, turn off the power to the circuit at the circuit breaker. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical circuits when you are wet or standing in water. Be aware of your surroundings and avoid distractions. Follow all safety precautions and code requirements to ensure a safe and successful wiring installation. If you are unsure about any aspect of the wiring process, consult with a qualified electrician. Continuous learning is key to staying proficient in electrical work. Attend training courses and workshops to learn about the latest code requirements, wiring techniques, and safety practices. Read electrical trade magazines and journals to stay up to date on industry news and trends. Join a professional electrical organization to network with other electricians and share knowledge and experiences. By continuously learning and improving your skills, you can provide high-quality electrical services and ensure the safety of your customers. The proper selection and use of wiring methods are crucial for ensuring the safety and reliability of electrical installations. Common wiring methods include non-metallic sheath cable, armored cable, and conduit. Non-metallic sheath cable, commonly known as Romex, is a flexible cable that consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is commonly used for residential wiring because it is relatively inexpensive and easy to install. Armored cable, also known as BX cable, is a flexible cable that consists of 2 or more insulated conductors enclosed in a metallic sheath. It is more durable than non-metallic sheath cable and is often used in commercial and industrial applications. Conduit is a rigid or flexible tube that is used to protect electrical conductors from damage. It is commonly used in areas where the wiring is exposed to physical damage or moisture. The type of wiring method you choose will depend on the specific application and the code requirements. Always consult with a qualified electrician or electrical inspector to ensure that you are using the appropriate wiring method for your project. Grounding is an essential aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, which helps to protect against electric shock and equipment damage. The grounding system consists of a grounding electrode, a grounding conductor, and equipment grounding conductors. The grounding electrode is a metal rod, pipe, or plate that is buried in the ground. The grounding conductor connects the grounding electrode to the electrical panel. Equipment grounding conductors are used to connect the metal enclosures of electrical equipment to the grounding system. The NEC provides detailed requirements for grounding electrical systems in Article 250. Ensure that your electrical system is properly grounded to protect against electric shock and equipment damage. Electrical panels are the central distribution point for electricity in a building. They contain circuit breakers that protect the branch circuits from overcurrents. Electrical panels should be properly sized to accommodate the expected load. They should also be installed in a location that is accessible and free from obstructions. The NEC provides detailed requirements for electrical panels in Article 408. Ensure that your electrical panel is properly sized and installed to provide safe and reliable electrical service. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to avoid injury or death. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these guidelines and best practices, you can ensure that your electrical wiring is safe, reliable, and compliant with the code. Always prioritize safety and consult with qualified professionals when needed. Remember that local codes and regulations may vary, so it is important to check with your local building department or electrical inspector to ensure that your wiring installation complies with all applicable requirements. Staying informed and adhering to safety guidelines will help you create a safe and efficient electrical system.